So we have this question number 100 from LeetCode, and it's a binary tree problem. And we are provided with two trees, and we need to check, we need to write a function if they are same or not. They are considered same if they are identical structurally also. So, and node also have the same value. So for example, these are similar, ditto similar, but these are not structurally identical because this is at left and this is at right. This is a left node, this is a right node. So this will be false, and this 1 2 1 1, this will be false again because even though they are identical, their node values are not same because there it is 1 and there it is 2. So here's the code. If you want a quick code, here's the code, but I'll be explaining this into depth because I have learned a very important concept from this, and I'll explain you what. So we have these two trees, okay. So here we have three conditions, okay. We'll directly jump onto the solution. We have three conditions. We need to check in these two trees. I'll just use this picture. Give me a moment. I'll just use this picture. We have these two trees, okay, and we need to check that if they are similar or not. First condition, very primary condition, whenever we are provided with node, we'll be provided with this node and this node. I'll write this as P and I'll write this as Q, okay. First condition we need to check if both nodes are null. If these are null, for example, if there is no tree present, if both are null, so that mean, like, technically that mean that they are similar. So we'll return true, that if nothing is present in both the nodes, basically they are same and they also have the same value. So technically we'll return true. If one node is null but other is not, basically what I'm trying to say, first thing, if both nodes are null, which means nothing is present, then it's obviously true. But if out of these two nodes, I'm just talking about first and first, this P and Q, I'll just name them P and Q for better understanding. Just a moment. So this is P and this is Q. These are the node which we are provided with. These are the nodes which we are provided with. These two nodes. Okay. So if P and Q, if one of them is null and other is not, which means they cannot be same ever. For example, I'll just remove one from here and I'll keep null here, which means this tree does not exist. Okay, this tree does not exist, but this do exist. So can they be same? No, obviously they cannot be same, even structurally and all that. They cannot be symmetrical. So this will return if one node is null, this other is not. This will return false, obviously. Now, third condition. If both nodes are different, I'll just change the value to 2, okay, and I'm saying they are not null but the value is 2 now and the value is 1. So value of P and value of Q are not same. So can they be same? No, they cannot be same because they are same only if the node also have the same value. So they cannot be identical. Okay, three conditions done. First, both are null. Second, one is null. Third is both are different. Now we jump on to the most important condition. Let's imagine that neither they are null, okay, nor they contain any different value, and neither of them is basically null. So these are same value, okay, these are same value. If both nodes are same, if both nodes are same, what you need to do? You just need to start traversing that. We need to see other nodes too, na. For example, first node is check, okay, ye wala theek hai. Then you also need to check other nodes also. So what will you do? Basically, DF is depth first search. You'll start going to left. You'll start going to left. Okay. You'll check this with this. Then you'll go right. You'll go right. Then you'll check this with this. If everything returns true, basically your whole tree is similar. Okay. That's it. Very simple. That's it. So I'll explain the fourth condition. Very important condition. If the nodes are equal, basically, if the nodes are equal, I'll jump onto the main code. Yep. Yep. I'm sorry. If the nodes are same, if the nodes are same, then here's the code. Here's the code. First, I'll explain the overview of code with in relation of these three conditions which I have written. First condition: if both are not null, oh sorry, if both are null, if both are null, return true. Okay, sorted. They are same. If one of them is null but other is not, if any of them is null, return false. I've already told you. Again, if the values are not same, for example, here we have 2 and here we have 3. If the values are not same, value of P is not equal to value of Q. Again, it's a false condition. Okay. Now, most important condition. Both of the values are same, and now we want to traverse. Now the most important thing which I have learned from this, that we can traverse with two nodes, two different nodes. Earlier when this question was presented to me, I was confused that if we can just use two values or not, because I haven't done any type of question like this. So I was confused that if we can use two trees, basically two tree nodes, so tree node P and tree node Q. So I have, while solving this, I have learned that definitely we can use it. So now, we'll talk about this return statement. It might be seem, gigantic to you, because earlier for me also it was quite weird. So we'll discuss about this. Now, just imagine that the values are same, okay? The both the values, this is same as this queue, okay? These all three conditions were not validated. Now we are into this. Now, look, just ignore this return statement and listen to what I am saying. For example, you went to the left, okay, you went to the left and you went to the left. In both you went to the left, okay. What I'm doing, I'm just traversing. I'm doing nothing special, I'm just traversing in my both of the trees at same time. Just remember this. P first, I'll just change the color. Just a second. This P, first tree. Q, second tree. So I need to traverse in same fashion also. Okay. So I went left and I went left. On both I went left. After going left, how will I, like, just ignore the statement, just ignore the statement, and I'll write something of my own. I'll write something of my own. How will go left? How will go left into something? We'll use this if I want to go left in tree. If I want to go left in P, basically what I'll write this P left, sorted. If I want to go left in Q, what I'll write Q left, obviously both, okay. What these will do, these will take me to this two node and two node. Now currently I'm standing on this node. I'll mark it also. Currently, I'm standing on this node and I'm standing on this node. Now again, the recursion will happen. Again, recursion will happen. How I will go? यहाँ पे, I'll just write. If I'm standing on this and someone asks me that take me to this, what I'll do? I'm just writing a code here. I'll call my recursive function. Obviously, here my function is same tree. Obviously, I'll call my uh, function and I'll pass my value P of left. That's what I'll be doing. If it's a single function, I'll pass, just imagine that this is P, okay, and this is the left of it. So I'll pass this value. What this will do, this will make a recursive call, and again I'll come here, just ignore all this, again I'll come here, and again these condition will be checked, okay, sorted, nothing else, nothing special here. Now, imagine I'm standing currently on this in both the nodes. I'm standing on this. Now what I need to check, what all these parameters will be checked again. Obviously they'll be checked again with reference to this and this. Like earlier we were comparing 1 and 1 of P and Q. Now we are comparing 2 and 2 of P and Q. Okay. Now the whole process will go again. That's how recursion works. So are they two null? Definitely they are not null. So this will not execute. Are they two different, or basically are any one of them is null? No, nothing is null, and definitely none of them is null. Like just understand these two are these are very easy. Again, third statement. Are they two different? Are they different? No, they are not different. This is also 2 and this is also 2. So they are not different. Okay, these three again will not be executed. Again will fall into this condition. Okay, ignore all that. Just listen to this. From this 2, I'll again make a left call. From this 2, I'll again make a left call to check what lies behind that. What lies behind that? Once I'll make a call to the left of this and to the left of this, this will again call this tree. This will again call this tree, and I'll enter again. I'll enter again here. Now, how I'll enter? I'll enter with this 2 left, left of 2. I'm going towards left of 2. This is my 2, and I'm going towards left of 2. But surprisingly, what's there? There's nothing. There is null. There is nothing. Yeah, exactly. My point. There is nothing on the left of 2. So once I'll come onto this place, this will check, are these both null? Are these both null? And eventually this will be true, because next values of 2 of both of these trees are null basically. So this value will be executed true. This condition will be executed and I'll just return 2. I will not check the whole loop again. Sorted scene, very sorted scene, and this will return null to, this will return true to me. I mean, sorry, this will return true to me, and again this will return true to me. Sorted, this will return true to me. That's it. That's it. Nothing else. Now, how you traverse a tree? First you go left, then you go right. First you go left, then you go right. We have checked for left. Left returned us true. Now we'll jump on to right. Same thing will happen on to right also. It will check if there are some values or not. Again, this condition will held true, and this will return true again. That this is false basically. False, I mean, this is empty. This is null, not false. This is null basically. Both have returned 2. Now, look at this scenario. I have a node of this. I have a node of this thing. Okay? This contains 2. This also contains 2. From this, I got true. Okay, from this, I got true. From this also, I got true. And from this also, I got true. So what this will return to the left of it. For example, here we have 3 and here we have 3. What this will return to the its parent value basically, if both are true, and you add a condition of and in between them. You have we all have read this, na, true and true and condition. Like there's a or condition if both are true, and if also I'll not deep dive into this, but the whole condition is I'm using these double ands, which means this and true will only give true, and all other values, if even a single value is false, if even a single value is sorry, true and false, this these all values will be returning false. The only value which will be returning true is this true value when both the conditions are true. So now I've asked you to ignore this return line, na? Now jump back to jump back to this line. Yep, we have checked is same tree left. We have checked for the left, we have checked for the left, then again we have checked for the right also. While standing on this 2, we have checked for the right also, again sending the recursion right also. This right just a second, this right gave me true. We know that I have just shown you that right of this 2 is true. Again, right of this 2 is also true. So when these both are returning me true, so this whole condition will be true. Sorted. The left of both of these conditions, left of both of these conditions have returned me true also, have returned me true. This is also true. Now, if this is true, and I have a condition of and, so I have this condition T and T. So what this whole thing will return, this true and true will return eventually true to my 1. Like get this point. I'll just remove all this. Give me a moment. I'll remove all this and I'll tell you in a very simplified manner. This returned true. This returned true. Sorted. This returned true. This returned true. What this will return? Of course, this will return true. Of course, this will return true. Sorted. In the same fashion, like we have traversed left, we will also traverse right in the same fashion. And this right will also again return true. This will return true. And this right will again return true. This will also again return true. Once we are out of our recursion, the whole tree will be returning true, which means there was not any case where either of them were null or they had a different value, which means that the tree was symmetrical all the way. All the way it was symmetrical. I'll explain same thing with this. I'll explain quickly with this. 1, 2. It is in the left. 1 and 2. It is in the right. Okay. Whenever I'll call the left function and whenever I'll call the left function, this will return null. So we know the condition. We know the condition. If any of the node get null, if any one of the node gets null, we return false. So this will return false. Of course, this will return false. But here, this will be true because it's null. This will be true. Obviously, it will be true. Now, when this will return back, this will return true, but this has returned false. True and false. And we know that T and F results into F only, which means they cannot be identical. This whole tree will return false. You just need to understand this and take a moment to grab those things, because it's not practically possible to draw me a whole tree of recursion. Like it will be a video of more than 30 minutes if I deep dive into those things of explaining that how each and every step, like how this works and how this went back and all this. Definitely, I need animation, and there are much better teachers than me. So even I'm not a teacher, the whole thing was, this main concept was that how I'm using these two values for this is exclusively traveling left, this is exclusively traveling left in both the trees at same time, and this is exclusively for traveling right in both the trees at the same time. And if we want, we can write them separately also. I can write this condition separately in a boolean. For example, how will I write this? I'll tell you, give me a moment. Yep, I can take a variable, I can take a variable of boolean left, and I can insert this whole value. I can insert this whole value here, okay? And I can insert a boolean right. Then again, I can insert this whole value here, okay? Once I have left and right, once I have left and right, like imagine them. I am standing on one, and I've asked my left variable that what's your status. Then left, and just remember this, that this left will not only consider this, but this will also consider this node also. So I've asked my left variable what's the status of these two trees left. So this will return me true. Now I've asked my right variable what is the status of these right subtree. It will again return me true. So when they both will return me true, what I can do, I can just do return left and right. This is, even if this feels complex, then what I can do, I can use if else condition. If left is equals to right, or if left is true and right is true, then return true. I can use this method also. So this was important because we have another question coming up in the same fashion, where these value will be manipulated. Like it's a brilliant question. Like I'll say, it's a brilliant question of lead code, where we are traveling in normal fashion. Na? If you understand this, you'll understand that very quickly. So we are traveling in normal fashion. In next question, we would be required to travel in opposite fashion. I'll just tell you why in next video.